What up, pre-calculus? I had this all recorded during fourth period yesterday, or Monday, Friday, and then it disappeared, the recording. So doing it again. Gonna try to make it shorter. We're switching gears from an x that we can isolate, where like here, x squared minus 25, we can isolate the x by adding 25 and square rooting to get two solutions, positive and negative 5. To a situation where we can't isolate x. We can't just get x by itself by undoing what's being done, okay? And equations that we're going to focus on where this can't be done are quadratics, okay? Quadratic equations. Quadratic equations look like this. It's got an amount of x's, amount of x squareds, and numbers. And our goal today is just to find the x-intercepts or the zeros or the roots. These are all synonymous. It's also another way of saying solutions, but it's the solutions to your quadratic equal to 0, okay? And what we will find is that, yeah, if you just have a quadratic equation and you're asked to find the x-intercepts, which is when the y is 0, that's like, finding the x when the y is 0. You can't do it by isolating. Okay, we have two different versions of x. We have x squared and we have 6 x's. Those can't be combined, which means we can't isolate. You might think of subtracting 5. It doesn't work, okay? So what we have to realize is that having equations equal to 0 is beneficial if we could turn the sum into, and this is our goal today, reviewing, turn sums into products. Products equal to 0 are great. Because if a piece of a product equals 0, like if this is 0, well, 0 times anything is 0. If that's 0, well, anything times 0 is 0. So beneficial to have things being in a multiplication form, a product form, because easy to make a product equal to 0. And what we'll find is that you can multiply two things by two things. X's times x's are x squareds. So ax plus b plus cx plus d multiplies to get a version of this. Like we got acx squared. We'll call that big ax squared. We'll have an amount of x's that we can combine. We'll call that big bx's, and then we'll have a number at the end. So like products of x's and numbers turn into quadratic equations. So that's our goal. We understand products of x's and x's give us quadratics. So we're going to review distribution. We do this because we know that if I wanted to set this equation equal to 0, we can easily solve this equation set equal to 0. So when we have 2x squared plus 10x, we are going to attempt to undo the distribution, find the zeros. Okay, but for right now, we are just making sure we understand what happens when you distribute x's to x's. Okay, a lot of people sometimes use the box, x minus 7 times x plus 3. A lot of people use arrows. I'm more of an arrow guy. You get x squared, you get 3x's, you get negative 7x, and you get negative 21. What you'll find is that you will combine your x's to get negative 4x's, and we'll talk about how we can find that a little bit easier in the future. Here, x plus 1 squared. It's important not to make the mistake of doing x plus 1 like x squared and 1. You have to write it out. And get that it's x squared. I'll have a 1x, I'll have another 1x, and I'll have a 1, giving me x squared plus 2x plus 1. Okay, so we reviewed distribution. Now, our goal next is to make sure we really understand distribution. What do we notice when we're multiplying x plus a number times x plus a number? That the two numbers, negative 7 and 3, add to get the middle term, and the two numbers multiply to get the last term. Okay? This two number 1 plus 1, and this is 1 times 1. That way I know that x plus a number times x plus a number is going to be x squared plus an amount of x's plus a number. And I know that it's the two numbers 3 and 1 that will help determine what the amount of x's are and what the last number is. It's very important to say it's like 3 times 1. It's definitely going to be 3. I know I'm going to have 3 here. If I understand distribution, it will help us tremendously when we learn how to undo distribution and turn things into a product. So here we have x squareds, we have an amount of x's, and we have that. It's all about these two numbers that will determine our last term, negative 5 times 3, our middle term, negative 5 plus 3, and we're good. Okay? Same thing here. We're just going to have negative 4 twice, negative 4 times negative 4, negative 4 plus negative 4, and that's the same deal, so we'll skip it. Okay? And the advantage of having things in factored form is because it's easy to find zeros. If I have this equation set equal to 0, it's easy. As long as one piece of my product equals 0, everything equals 0. Here, x could equal 0, x equals negative 5. Here, as long as one piece of my product equals 0, everything will equal 0. Here, x equals 7, and x equals negative 3. Okay? Here, as long as one piece of my product equals 0, the whole thing is equal to 0. Well, x could equal negative 1. That actually occurs twice, but we're just going to say that's the number negative 1 that occurs. Okay? So, if we want to find when these equations equal 0, we are going to turn them into their factored form. Turns out J is 2x squared plus 10x. Turns out K, x minus 7 times x plus 3. Well, x minus 7 times x plus 3 is x squared minus 4x minus 21. If I have this equation and I want to solve, if I have this equation and I want to solve, if I have this equation and want to solve, I'm going to undo distribution, turn it into this, or turn it into this, turn it into this, so that we can solve. We're going to undistribute, turn this into its equivalent undistributed form. We'll talk about how to do that in a second. Turn this into its equivalent undistributed form. We'll talk about how to do that in a second. Turn this into its equivalent undistributed form. We'll talk about how to do that in a second, because then we'll have our solutions. Got it? Cool. So, how do you undistribute? Here are some things you might have to do to undistribute. First thing is undoing a greatest common factor. This is like having this type of thing as our resultant undistributed form of our quadratic, where we can see 2x is multiplied into both of these terms to get 2x squared and 10x. Well, if I want to undo the distribution, I want to see what can I divide out of 2x squared and what can I divide out of 10x. I'm going to divide, or think about pulling out, what the largest thing that these things share. Well, like 3 and an x is shared. Now, if you're undoing distribution, make sure that when you distribute, you're going to get what you have. So 3x times x is 3x squared. 3x times 4 is 12x. You might be familiar with doing this with like a box. If you like to use box for multiplication, you can undo multiplication by undoing the box, like that. We have this set equal to 0. We have two pieces of the product equal to 0, 3x equaling 0, x plus 4 equaling 0. Solve this by dividing by 3. Solve this by subtracting 4. Okay? Here, it's up to you what you want to pull out, but it's like 8 and 12 both share 4. I can multiply 4 in to get 8 and to get 12 different ways. They also both share an x. Maybe you factor out a 4. Maybe you factor out a negative 4. Just make sure after you undo the distribution, it's going to work out. I almost just made a mistake. I almost just put 4 and then 2x. Well, 4 times 2x is 8x, not 8x squared. This is why, like, always think about what you're doing. You're not changing it. You're just making it look different. Maybe we have this. Okay, we're finding the zeros of this, which means we're finding the zeros of this, and we have this product equal to 0. Now to solve this again, take each piece of the product and set it equal to 0. Well, this guy, again, divide by 4, I get x equals 0. It shows up again. This is not obvious. So far, it's been obvious what my answers are. This will not provide an obvious answer. I need to find what the answer is by solving. Or saying, like, -2 times what gives me -3, so -3 plus 3 is 0. Well, you can just kind of figure out divide by -2, divide by -2. +3/2. Probably can't see that because of my face. +3/2 would be a solution. 3/2 times -2, -3 plus 3. Boom. Okay? So that is the first technique of factoring. Second, undoing a factoring. Remembering that if I have x plus a number, I'm going to use 5 and 6 times x plus a number, that when I distribute this, and we practice this, we get x squared plus 11x's plus 30. Remember, in between you'd have x squared, you'd have 6x's, you'd have 5x's, and you'd have 30. Okay, this is distributing everything or using the box. Now, what do you notice? The number 5 and 6 adds to get 11 and multiplies to get 30. Our goal is to take this and turn it into that. How are we going to do it? We're going to find the two numbers that go there and there. And those two numbers need to add to get -4 and multiply to get 3. I like to do this instead of using the x. I don't use the x because if you put things in different order, you might make a mistake. If you put -4 in front of 3, you might be saying, oh, the numbers are +4 and -1. I don't want you to do that. Instead, I want you to think the two numbers have to multiply to get this last term. 5 times 6 is 30. Okay? -3 times -1 gives us +3. -3 plus -1 is -4. So those are my two kind of number puzzle numbers that we come up with. It's my understanding of distribution that leads me there. And now I can get the solutions. X could equal 3, makes that 0. X could equal 1, makes that 0. Same thing here. I know that x squared plus an amount of x's plus a number is x plus something times x plus something. The two numbers that add to get 5 and multiply to get 6. That's what I'm looking for, okay? 2 and 3, add to get 5, multiply to get 6. That's what we do. Don't use anything else. It's too complicated. Sometimes we'll have to undo a greatest common factor and the product of two binomials, which means we see this, we think we can factor it. The best thing to do is to undistribute one thing, divide out 6 by all 3. Again, check to make sure. Is this distributed equal to this? You're undistributing here. That's factoring. Then number puzzle it. X plus something times x plus something gives us x squared minus 2x minus 3. The two numbers that add to get -2 and multiply to get -3 are -3 and +1. Now we get to our solutions, and I want us to be careful here. The values for x that make the left side 0 are my solutions. Well, here is one x and here is another x. What can go into those x's to make the left side 0? Well, for this x, if I plug in +3, it makes the left side 0 because it's 0 times 6 times something else. For this x, if I plug in -1, we get 0. Those are the only two x's I see. Now, a lot of us look over here and we say, oh, but Mr. Messner, you had something on the outside, kind of like here. You had something on the outside. And when we had something on the outside, we got the solution x equals 0. But no, we don't have an x on the outside. So we can't plug in 0 for x to multiply in and get 0. So 0 is not a solution here. Okay? This one, it's beneficial to factor out a -1 so that we can then factor x plus something times x plus something. I'll just give you a little piece of advice. A lot of you might think about dividing out 6 or dividing out a -1. We'd recommend not doing that. You will get the right answer, but in the future, we are going to do more like analysis of these functions and analysis of polynomials, and signs are very, very important. So we'd actually recommend don't divide out constants, just leave them on the outside. The two numbers that add to get -8 and multiply to get 16 are -4 and -4. Got that. Now, to the tricky ones. If I notice that the first term is not x squared, what we're going to have is a situation where we realize we could have numbers before x's that when get multiplied create this number 2 or this number 5. We need to realize that those numbers will be incorporated into the amount of x's so that it's actually this amount that includes this, and this, all 4 things, A, B, and C, D. And then we realize that the two numbers multiply to get the last term. That's actually important that the two numbers multiply to get the last term. Okay, so there are lots of different techniques to factor this. Okay, I'm going to show you all 3. Here's a technique I think most of you learned if you were in On-Ramps Algebra 2 or most of the pre-AP Algebra 2s. You learned this technique, which is take A times C. Now, A times C includes AC and BD, which includes all 4 of our numbers. And A times C is 30. We are going to find 2 numbers that multiply to get that. But the 2 numbers also need to add to get the middle term. So the middle term, -11, we're going to find 2 numbers that add to get that -11. Now, the reason why we're doing this is we're going to actually back up 1 step at a time to get here. We're going to go from an amount of x squareds, and then we're going to go 1 step before that, and then we'll go 1 extra step before that. Thanks. Appreciate it. All right, so here's what it looks like. It's very hard to explain why this works, but the 2 numbers are -6 and -5. Now, what some teachers do is they say, okay, you need to split this up into amount of x's and amount of x's. Now, this is confusing to say, but like you're just undistributing 1 extra step along the way versus just going straight to your answer. What you do is you take your middle term and you rewrite your middle term, your -11x's as -6x's and -5x's. Okay? Now, after doing that, we factor by grouping, which is like take 2 things, both 2 things, and try to factor out the greatest common factor from each of those. Making sure that after you factor them out, that whatever is left is the same. And then what we end up seeing is that after factoring out the x minus 3 from both of these 2 terms, you get x minus 3 times 2x minus 5. And that's my solution. That's my factored form, my undistributed form. That's great. That's one way to do it. Here's another way to do it. And if that's your way, go back and figure it out. Another way to do it is to do the number puzzle. Boom. But instead of factoring by grouping, create a box. And it's kind of just like undoing distribution. We're going to have those two middle terms, that negative 11x split up into negative 6x and negative 5x. Now, the reason why we do this is because it's actually easy to like undo the distribution of the box. All you have to do is like look at any two terms in like a row or a column. Like, let's say this, 2x squared and negative 5x. What is like the biggest thing that can multiply in to get 2x squared and 5x? Well, it's like x. X is the only thing. Now, the reason why the box is so nice is because you can kind of work the multiplication puzzle out from here. Just having this one x, you could be like, well, what multiplies by x to get 2x squared? It's like, well, 2x times x is 2x squared. What multiplies by 2x, or what multiplies by x to get negative 5x? Well, minus 5. What multiplies by 2x to get negative 6x? Well, a negative 3. And all of a sudden, you see the factors 2x minus 5 and x minus 3 have to multiply to get 2x squared minus 11x plus 15. So this is the box method. Finally, the Mr. Mester method. Here's the Mr. Mester method. Yo, figure it out. What do I mean? The first two terms need to multiply to get 2x squared. Okay? That's how you can get 2x squared, is if you have 2x times x. The last two numbers have to multiply to get 15. Your options are 15 and 1 or 5 and 3. Now, somehow, if you combine these things, you need to be able to add your middle amount of x's to be negative 11. Now, I can think about having negative 6x's and negative 5x's. Well, the reason why I get negative 6x's is 2 times negative 3 gives me negative 6x's. There's that 3. And then negative 5 times x is negative 5x's. Like, I can just think about distribution. It'd be like 2x squared, negative 6x, negative 5x, positive 15, boom. The ones we're going to give you are easy enough that you can do this method. Just like the figure it out method. Then we solve. Set this equal to 0, add 5 divided by 2, set this equal to 0, add 3. Okay? Watch. 5x times x gives me 5x squared. That's the only way I can get 5x squared. 6 and 1 or 3 and 2. And I got to get 7. One of them's got to be positive or negative. I don't want to do 6 times 5, that's 30. I can do 6 times 1, that's 6. 5 times 1 is 5. So I'd get 6 and 5. That's not going to give me 7. So I know I'm going to have to do 3 and 2. If I do 10, 5 times 2, and then 3 times 10 and 3 gives me 7. Boom. Positive 10, negative 3. Those two numbers add to get multiply to get negative 6, and if I combine them, I get boom. So I just figured that out. Now, let's say you don't want to do that. I'm going to do the box. If you know how to group, great. Here's the box. A times C, negative 30 again. Negative 30 again. B, 7. Two numbers. Positive 10 times negative 3, positive 10 plus negative 3. Rewrite the middle amount of x's. Undo the box. X times 5x times 3x, boom. Like x is the only thing I can have. That means this has to be 5x. This has to be 2. This has to be negative 3. Boom. Got it. All right, then we just solve. I kind of tried to show why this works. It's confusing. It's confusing why it works. I'm not even going to bother. All right, give us to the last couple questions. This has to be negative 24, where I might ask you, hey, solve these equations. Yeah, you see x minus 3 times x plus 1, and that equals 12. And it's like, okay, 3 and negative 1. Well, now 3 and negative 1 don't work. If I plug in 3, I get 0. 0 doesn't equal 12. Plug in negative 1, I get 0. It doesn't equal 12. So what we realize is like we don't have what we want. You might think, oh yeah, I got to have things set equal to 0. And you might subtract 12. But again, that doesn't help you because you can't figure out easily by looking what the numbers are. Don't start guessing and checking. What you want to do is actually distribute, get that 12 over there, combine, and then factor to solve. So I'm going to use my understanding of distribution to quickly distribute. And then I'm going to subtract the 12 and realize that, oh, this quadratic can only be solved by factoring or undoing the distribution of x minus 5 and x plus 3, giving me my solutions 5 and negative 3, which are not obvious from these two options. Same here. You want to solve this. Well, it only helps if things are distributed, maybe in the correct standard form. And then the two numbers that add and then multiply. This one, same deal. Make sure you know how to distribute. Make sure you know how to combine everything, because it's only advantageous if we have everything on one side. Whoops. Negative 8 plus 1 is negative 7. So this is negative 4, negative 3. Those are the two numbers that add to get negative 7. This one we screwed up. It's got to be a negative 24. You get 2. I'm going to probably distribute the x minus 2 and the x plus 1. X minus 1. X squared minus 3x plus 2. Plus negative 24. It's 2x squared minus 6x plus 4 minus 24. That's 2x squared minus 6x minus 20. I will now factor out a greatest common factor. And I get x minus 5, x plus 2. In the original notes, that's wrong. I'm just finishing up a video real quick. But give me 2 minutes. I'm literally done. All right. This is a free response type example where it's like we start out in a factored form, but different questions could be asked of us. Like, here's one question. Find A, B, C. Okay, I'm going to distribute. I'm going to distribute some more. Boom. There's A, there's B, C. A is 2, B is 14, C is 24. Find the x-intercepts. Easily done. I can see negative 3. I can see negative 4. Don't include anything else like 2. If you plug in 2 for x, you don't get 0. The y-intercepts, don't forget the y-intercept is when x is 0. When x is 0, f of 0 is 2 times 3 times 4. 12 times 2 is 24. That's the y-intercept. And the final one, when is f of x equal to 12? This is where it looks like, oh, we could figure this out, but no. We have to distribute. We got to get everything onto one side. Factor. Factor some more. we got it. Okay? That's it. That's reviewing of solving quadratics that are undistributable. See you out there.